What's up, people? We are talking about antiderivatives and indefinite integrals now. So far we've learned how to find the integral between two bounds, so like the area under a curve between bounds. And now we're going to talk about finding the integral without bounds. So like if we're given the derivative, and now I want to find the original function. So like if I'm given velocity, now I can find my position function, right? So my original function f of x is called the antiderivative, so like the opposite of a derivative, antiderivative, or we can say the indefinite integral of f prime of x. All right, so this symbol here is the antiderivative of g of x, okay? And the term antiderivative is a synonym for indefinite integral. And again, this is different from what we've done already. We've done definite integrals. Okay, those are our Riemann sums, more or less. And now we're going to talk about indefinite integrals, just meaning that we don't have bounds. Okay, so we have a bunch of rules here. So just like our derivatives, we have some things we need to memorize. Okay, so we have like power rule and stuff over here for our derivatives, our snow cone, all that stuff. And now we're going to go to like reverse power rule. Okay, so very similar to what we've done. The only thing that you're going to do now is do the opposite. So now we're going to add 1 to our exponent instead of dividing. Instead of bringing it down and multiplying, we're going to divide by our new exponent. All right, you'll also notice that at the end of each of our antiderivatives, we have a plus c. The reason for that is because keep in mind that this inside here is the derivative. Okay, so and this is my original function. So if I take the original function, like for instance sine, and I took the derivative of sine is cosine, and the derivative of any constant like 5 or 6 or whatever, the derivative of any constant is going to be 0. So I end up just having cosine of u, okay, which is what I have on the inside, so that should match. So because this could have some constant, all right, and my original function could have some constant, and if you took the derivative, that constant would go away. I don't really know what my starting point is, and so I need to include that plus c. All right, so I got some properties. We already talked about these with our definite integrals, and the same ones apply. So plus or minus, and then drawing a constant out. So let's practice now. So first, I have a polynomial. I want to take the integral. And so the process is I have a constant, so that's just going to chill in the front. Now I have 3x. I'm going to add 1 to my exponent. So instead of 2, it's now going to become a 3. And then I'm going to divide the whole term by my new exponent. All right, let's try again. So it was a 1, now it's a 2, and I'm going to divide everything by my new exponent. Those match. 4, and you can kind of imagine this like x to the 0. So it was 0, I'm going to add 1 to that, so now I have x to the 1, and I'm going to divide by my new exponent, and then I stick a plus c at the end. All right, we can simplify this sum, so I'll just get x cubed minus 5 halves x squared plus 4x plus c. And that is my answer. So like this is the original function, that was the derivative. And you can always check your work. All right, so if I take the derivative of this, so if I take the derivative, I'll get 3x squared minus 5x plus 4. This should match what was on the inside of your integral, or we also call it the integrand. Okay, next example, there's no product rule or quotient rule, so we have to simplify this. We have to do the binomial distribution. And so I'm just going to multiply. I get 2x squared plus 6 minus 1, so plus 5x minus 3 with respect to x. Now keep in mind, the way that I've written it, it's very specific. And I put the parentheses here to show that the integral is applying to every term. And I put the dx at the end, and this is very necessary. If you don't put it, you will lose points. Now let's take the derivative. Sorry, take the integral. So I have 2x. Now it was squared, so now it's cubed, and I'm going to divide everything by 3. It was to the first, now it's squared, divide everything by 2. And then I stick an x here, and stick a c at the very end. All right, same deal here. So instead of thinking about this like square root of x, I'm going to think about it as x to the 1/2. Okay, now if I'm dividing by a term, I can divide every single one of these on the top by my bottom term. So now, instead of x squared, I have x to the 3 halves. All right, so remember when you're dividing exponents, you just subtract. Or when you're dividing the bases, you just subtract the exponent. So I have x to the 3 halves minus 2x to the 1 half plus 7x to the negative 1 half. All this goes in parentheses, dx at the end. All right, now let's take the integral. We got fractions. So I'm going to add 1 to 3 halves. That becomes 5 halves. And I'm going to divide by 5 halves minus 2x. It was 1 half. Now it's going to become 3 halves. And I'm going to divide by 3 halves. So the process does not change for negative exponents or for fractions. All right, then I had 7x. I add 1 to here, so I get 1 half. Now I divide by 1 half. And then plus c at the end. Now let's simplify this sum. All right, so dividing by a fraction is the same thing as multiplying by the reciprocal. All right, and another way that I think about this is I just think about like what could I put in the front here that would counteract multiplying by my exponent. So I know 5 halves will cancel out with 2/5. That's another way that I think about it. Okay, now I'm going to multiply 2 by 3. I'm going to divide 2 by 3 halves. Same thing as multiplying 2 by 2/3. That's 4/3. All right, and then plus 7 times 2 is 14 to the 1 half plus c. And here is my original equation. Or we can call this the general equation. All right, let's keep going. All right, now they give us a differential equation, and that pretty much just means that we're given the slope. We have an initial condition here, and I want to find the original equation. That's my goal. All right, so again, I can take the integral. So we'll take the integral of 6x squared with respect to x. And so again, I'm going to add 1 and then divide by that same power plus c. Simplify that to 2x cubed plus c. All right, now they gave me an initial condition. Right, and this initial condition means that I kind of know where I started. Now keep in mind what I just found here is equivalent to f of x. They told me f of 1 is negative 3. Which means that I should be able to plug 1 into here, and it should equal negative 3. And look, I have an equation with just c in it. So I can solve for c. So I know that negative 3 equals 2 plus c. So that means that c is negative 5. And so my original equation is 2x cubed minus 5. Okay, because I found that c was negative 5. All right, easy enough. Next one, now they give us the second derivative. I need to go back to the original function, so I'm going to have to take the integral twice, and they give me the necessary initial conditions for each step. Right now, so we're going to remember snow cone. We go up for integrals. All right, we're going to go up for integrals. So I'm going to take the integral of cosine with respect to x. Okay, so I'm going up. The integral of cosine is sine. All right, now I know that f prime of 0 is 3. Now keep in mind again, this was f prime of x that we just found. So f prime of 0 is 3, which means I can plug 0 in for sine. Sine of 0 is 0, so that means c equals 3. So that means f prime of x is sine of x plus 3. Okay, now f of x is equal to the integral of sine of x plus 3 with respect to x. The integral of sine is negative cosine. The integral of 3 is 3x plus c. All right, now I know that f of 0 is negative 2. So I'm just going to plug 0 into my function. So cosine of 0 is 1, so I have negative 1 here. So that means c is also negative 1, which means that my original function is negative cosine of x plus 3x minus 1. And now we're done. All right, last part. Now I'm given velocity, I want to find acceleration and position. Now I can do this. So remember, acceleration is the derivative of velocity. So I'm just going to take the derivative, and so I get 12t squared minus 6t, and I'm done. Okay, that's my acceleration. Now position is a little bit more involved for here. Position is going to be the integral of velocity. So I'm going to have to take the integral of 4t cubed minus 3t squared plus 5, that's a plus, with respect to t. Okay, so I'm going to get t to the fourth minus t cubed plus 5t plus c. Now they did give me an initial condition. They said at 2, my position is 3. So that means that s of 2 equals 3, which means I should be able to plug 2 in and solve for c. And I'll get that c is negative 15, which means that s of t is t to the fourth minus t cubed plus 5t minus 15. All right, that's it. See y'all later.